Hello, Algebra 2 students. Today we will be starting Unit 13, and it's a little introduction on trigonometry. Now, trigonometry deals with triangles, and in 13.1 we will deal with right triangles. So 13.1 notes are use trigonometry with right triangles. The ratios, remember ratio is just a fraction. So the ratios of a right triangle's side lengths define the six trigonometric functions. And these six functions are sine, cosine, tangent, and their abbreviations are SIN, COS, TAN. So whenever you see SIN, that's sine, COS is cosine, TAN is tangent. Then you have cosecant, CSC, secant, SEC, and cotangent, COT. A helpful acronym for remembering the six trigonometric functions is Sohcahtoa, and I'll tell you what that means in a second. But before I do, look at the right triangle that's been sketched on the far right. That angle there, this angle right here, is called theta. It's the Greek letter theta. And that's the angle that you're interested in looking from. So if you're standing there at theta, so just pretend like here you are a person looking at your right across from there, you would find the opposite side, and notice you see the opposite side. Next to you is what is known as the adjacent, and these are called legs. So it's opposite leg, opposite side, adjacent side. The hypotenuse, the easiest way to remember is the hypotenuse is always directly across from the 90-degree angle. And the 90-degree angle is drawn or is indicated by the little square in the corner. So right across from the 90-degree angle is this hypotenuse, which is the longest side of a right triangle. And then the two shorter sides are known as opposite legs and adjacent leg. And so now that you know what theta is, and you know that a right triangle consists of a 90-degree angle and then two acute angles, we can define the six trigonometric functions. The sine of a theta is always the opposite side over the adjacent side, or I'm sorry, over the hypotenuse. And so this is where you get the acronym. So S stands for sine, O stands for opposite, and H stands for hypotenuse. For C, cosine, or C stands for cosine, A stands for adjacent, and H stands for hypotenuse, T stands for tangent, O stands for opposite, A stands for adjacent. So that's the acronym, Sohcahtoa. And notice if you look at these three right here, and then you look at those three right here, they're the reciprocals, meaning sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So they've just been flipped. So sine and cosecant are reciprocals, cosine and secant are reciprocals, and then tangent and cotangent are reciprocals. Now, students have no problem with tangent and cotangent because of the word tangent in there, so you can tell that they're related. But the way to remember the cosine and cosecant, so I always tell students it's never the same letter. So cosine and secant are reciprocals, and then sine and cosecant are reciprocals. It's not SSCC. It's in fact the opposite. So that's a good way to remember them. So we are going to say cosecant is the reciprocal of sine, so it's 1 over sine. Secant is the reciprocal of cosine, and tangent is the reciprocal of cotangent. So they are reciprocals of one another, and I am going to write. Now, if I said what's sine of theta is the reciprocal of cosecant, so it'd be 1 over cosecant. Secant's reciprocal is cosine. And then tangent's reciprocal is cotangent. It's 1 over tangent. There you go. Now, oops, before I get it too far away, going back to this right triangle, in a right triangle, and I'm just going to label these. I'm going to label the opposite side A, the adjacent side B, and the hypotenuse C. That's generally how you name the sides of a right triangle. So if a triangle is a right triangle, the two shorter legs known as opposite and adjacent, if you were to square those, so A squared plus B squared, those two squared sum adds up to equal to C squared. And C is always the hypotenuse. So that is known as the Pythagorean theorem. And it shows the relationship between the three sides of a right triangle, where C is the longest side, and like I said, it's known as the hypotenuse. Okay, now we are going to do examples 1 and 2 to round out the first page. Evaluate the 6 trigonometric functions of the angle theta. So I'm going to write my acronym here, Sohcahtoa. Always wise to write at the top of every page, and you always look from the angle theta. So you're always looking from this angle right here, or whatever theta, wherever theta is labeled. So that's theta right there. Made it really terrible looking. There, that's better. So when you're looking from theta's perspective, label your sides. This is the opposite side. This is the adjacent. And directly across from the 90-degree angle, this is 90 degrees, this would be the hypotenuse. Always label your stuff. Then it's easy to get the 6 functions. And so I'm just going to go in order. So sine of theta is, so if you look at the acronym, opposite over hypotenuse. So opposite side is 8, hypotenuse is, we don't know, because I got ahead of myself and I have to use the Pythagorean theorem to find out what the hypotenuse is. So a squared plus b squared equals c squared. So one of them, it doesn't matter which you put first. So 8 squared plus 15 squared, but you know the hypotenuse is c, and that's what we're trying to figure out. 8 times 8 is 64. 15 times 15 is 225. Add those two together, and that's equal to c squared. To solve for c, you must take the square root of both sides. We're only interested in the positive side. Triangles don't have a negative length. The square root of 289 is 17. So this side is 17. Okay, so now I can finish the problem. So sine of theta is 8 over 17. Cosine of theta is adjacent over the hypotenuse. So adjacent leg is 15. The hypotenuse is 17. Tangent of theta is opposite over adjacent. So opposite side length is 8. Adjacent side length is 15. Reduce your fractions if you need to. You don't need to. And now for the reciprocals. Sine's reciprocal is cosecant. And so just flip the numerator and denominator. Cosine's reciprocal is secant. And that would be 17 over 15. And then this one is cotangent. And that's 15 over 8. It's really not that bad. You might have to use the Pythagorean theorem to find the third side if it's not given, and we had to there. And then you list the 6 trig functions. All right. Now, for example 2, if theta, this time you have to draw the picture yourself. So if theta is an acute angle of a right triangle, and you could put it anywhere you want. I'm just going to put it in this corner. And cosine of theta, so we're going to look cosine, remember, so I better write it here as well. Cosine is adjacent over hypotenuse, so we know this number is top number represents adjacent, bottom number represents hypotenuse. So this is the hypotenuse. This is the adjacent leg, so that's 3. And we need to figure out the missing side length. This is the 90-degree angle because we know that the hypotenuse is 5. So again, we're going to use the Pythagorean theorem. So we have a squared plus b squared equals c squared. C we know is 5. That's your hypotenuse. Square it. But we don't know one of the legs, so we can just say we don't know A, but we do know B. Legs don't matter which one you put where. So a squared plus 3 times 3 is 9. 5 times 7 is 25. Subtract 9. A squared equals 16. And then take the square root of A, or square root of A squared, which is A. Square root of 16 is 4. So this happens to be 4. And now you can list your 6 trig. You can evaluate the 6 trigonometric functions. So sine of theta is equal to, okay, so now we know that this is, because we're looking from theta's perspective, so opposite, hypotenuse, adjacent. Okay, so sine is opposite over hypotenuse. Cosine was already given to us as 3/5. Tangent of theta is opposite over adjacent. So opposite leg is 4, adjacent leg is 3. And then these are easy. So cosecant of theta is 5/4. Secant of theta is 5/3. And cotangent of theta is 3/4. And there I evaluated the 6 trig functions of the angle theta. And that rounds out the first page. Second page, again, throwing back to geometry, special right triangles. Recall from geometry that special right triangles, and those are 30, 60, 90, because remember the 3 angles in a triangle add up to 180, always. Same with 45, 45, 90. Those 3 add up to 180 degrees, the 3 angles. They have special ratios of their side lengths that always work. And so I am going to show you how to label a 30, 60, 90 first, and then I'll show you how to label the 45, 45, 90. So in a 30, 60, 90 triangle, the shortest side is the side across from 30 degrees. And so here's 30 degrees, and the side across from it is always 1. The hypotenuse is twice that amount, so it's 2. And then the one that's across from the 60 degrees is between the two sizes, between 1 and 2, and it happens to be exactly the square root of 3. Okay, and then for 45, 45, 90, so these two, it's an isosceles right triangle. These two have the same length. These two sides across from each 45-degree angle is 1 each, so they're both have a side length of 1, and the hypotenuse is just slightly bigger. It's the square root of 2. So that's your ratio that you're just supposed to memorize. I mean, in geometry, you had to memorize them. I probably will never forget these 3. And then you list the ratio. So again, going back to our Sohcahtoa. Remember sine, and we'll do sine first of 30, then how's the best way to fill this out? We'll do sine of 30, then cosine of 30, tangent of 30, and so on. So the sine of 30 degrees is opposite. So the opposite leg is 1 over the hypotenuse, 1/2. Okay. Cosine of 30 is adjacent over the hypotenuse. So square root of 3 is its adjacent leg over the hypotenuse. Hypotenuse is 2. So I guess we can label it in each one. Okay, tangent of theta for the 30 degrees, tangent of 30 degrees, sorry, is opposite over adjacent. You cannot leave it like that because you cannot have a radical in the denominator. So simplifying it, multiply top and bottom by square root of 3. There we go. And square root of 3 times square root of 3 is just 3 in the denominator. Cosecant of theta is just the reciprocal of sine, and sine was 1/2, so this is 2 over 1. And then secant of theta is, so secant is the reciprocal of cosine, so it'd be 2 over the square root of 3, which we don't leave like that. So you multiply top and bottom by square root of 3. And then cotangent of theta is square root of 3 over 1, or just square root of 3. Okay, now let's jump down to sine of 60 degrees. So sine of 60 degrees, so looking at 60 degrees perspective, it'd be square root of 3 over 2. Cosine of 60 degrees would be 1/2. Hopefully you realize that you just switch from when it was sine of 30 degrees. Tangent of 60 degrees is square root of 3 over 1. Cosecant is 2 divided by square root of 3. So you're just flipping the numerator and denominator of sine of 60 and then multiply top and bottom by root 3. Secant is reciprocal of 1/2, which is 2 over 1. And cotangent is 1 over the square root of 3, which is square root of 3 over 3. Okay, now moving to our 45, 45, 90. The sine of 45 degrees, and it doesn't matter where you look from. You can look from this angle right here. The opposite's going to be 1, and the hypotenuse is going to be square root of 2. We don't leave it like that. Okay, this is going to be the exact same. Tangent is just going to be 1 over 1. And then these are just going to be the 1 over 2 flipped, so root 2 over 1. There we go. Okay, find the value of x in the right triangle shown. So I tell students to do this. Well, you know that this is 45 degrees, or these two are the same, because if this is 90-degree angle right here, and one angle is 45, the other angle must be 45 as well, for them to add up to 180. And so you know this is x also. And you know the relationship, it'd be x would be the two short legs, and the hypotenuse would be whatever x is times the square root of 2. And going back here, that's what I need to go fit that back in. So if this is 1, or just, if you want to call it x, or x, this would be whatever x is times the square root of 2. If this is x, this would be 2x, and this would be whatever x is times the square root of 3. And that's how you can label it. So the hypotenuse here is going to be whatever x is times the square root of 2 in a 45, 45, 90. So that will give you the length of the hypotenuse. So there's your equation. X times the square root of 2 is the value of the hypotenuse. So to solve for x, divide both sides by square root of 2. That cancels. We're left with x equals 6 over square root of 2, which you cannot leave a radical in the denominator, so you multiply top and bottom by radical 2. So that is 6 radical 2 over just 2, because square root of 2 times square root of 2 is just the number itself without the radical. And then 6 divided by 2 is 3. There's your answer for x. Okay. For the next one, example 4, we're going to use trigonometry for solving a right triangle. So what does it mean to solve for a triangle? It means find all sides and all angles. There are a total of 3 sides in a triangle and 3 angles in a triangle. And we're going to find all of them for this right triangle. Easiest thing to do is find all the angles first. So we know angle A is 54 degrees. It's in the picture. Angles are notated with capital letters. Angle B, we don't know. We know C is 90. It's really easy to figure out what angle B is because you know that the 3 angles add up to 180. So 90 plus 54 is 144. Therefore, this must be 36 degrees. So we are halfway done. We found all the angles. Now let's see which side lengths we have to find. We know C is 20, but we don't know A and B. So let's figure out A and B. And let's use trigonometry. So we are going to call this angle, since we know it, theta. And therefore, this would be the opposite side because you're looking across from theta. Hypotenuse is always across the 90-degree angle. And this is 90. And therefore, this is the adjacent. Okay, so we can use Since we know the hypotenuse, we must use either sine or cosine because only sine or cosine have the letter H in its acronym. It doesn't matter which one we use. I'm going to use sine because it's listed first. So sine of theta, and theta happens to be 54 degrees, is equal to the opposite leg, which we don't know, A, which we're trying to find, divided by the hypotenuse, which is 20. This is pretty easy, guys. All you do is you cross multiply to get rid of the 20. Okay, so 20s cancel, and we are about to figure out what A is. How the heck do we figure that out? Well, we take a calculator and you make sure that your calculator is in degree mode. So you do, depending on what calculator you have, if you have an advanced one, you just punch in sine first, then 54, there's no degrees because you're in degree mode, and then multiply by 20. And it gives you about 16.2. I'm going to round. Now, if you were using your phone, you would punch in 54 first, then sine, then times 20. So work from right all the way to left. You don't do 20 first, then it might get confusing. So I would do 54, but make sure your phone is also in degree mode. Okay. Now I'm going to use cosine to find B because we want to find the adjacent leg. So cosine of 54 degrees is equal to the adjacent leg, which is known as B, we don't know what it is, over the hypotenuse. So again, cross multiply. So punch in 54 in your phone, then cosine, then times 20, and you'll get about 11.8, and that'll give you the value of B. I marked that here, but I'm going to put those answers right here as well. So A is 16.2, and B is about 11.8. And here we have solved the right triangle because we have found all three angles and all three sides. Okay, example 5. You are hiking toward a main road. So here you are hiking along, but reach a point where the road is flooded. So you see the little water there. So here's the flooding. To avoid the flooded area, you turn onto a diagonal. So you're turning right here onto a diagonal road that meets your original road at a 48-degree angle, and follow that road for 3.6 miles until you hit the main road. So here you hit the main road. How far were you from the main road when you turned onto the diagonal road? So you want to find this length right here. And so let's label what we know. We know this is a hypotenuse because it's directly across the 90-degree angle. You're looking from this perspective, so call this theta. And therefore, we want to know the adjacent side next to theta. We don't care about the opposite side. We don't want to know how long the main road is. So we want to use cosine because we are interested in the adjacent side. That's length x. So the cosine of 48 degrees, that's theta, is equal to adjacent leg, which is x, over the hypotenuse. Multiply top and bottom by, multiply both sides by 3.6. So we have 3.6 cosine 48, and that gives you roughly 2.4. So to answer our question, it's about 2.4 miles. We were about 2.4 miles away before we had to take that diagonal. All right, in our last little topic, it's called angle of elevation. The angle that your line of sight makes with a line parallel to the ground is known as the angle of elevation. So this right here, this angle makes an angle with the line parallel to the ground. The other one is the angle of depression. And both of those angles are equal. That's the angle between a line parallel to the ground and your line of sight. Okay. So I'm going to erase that. And then we are going to do a problem. From a point on the ground, I'm going to draw the picture right below the vocabulary. From a point on the ground, 28 from the base of a flagpole. So I'll go ahead and draw a flagpole. And don't make fun of my drawings, because I am pretty bad at these kind of things. Here, I'll put 1 star here. There we go. The angle of elevation to the top of the flagpole. So here's the top. So not very good, but it's supposed to be straight because it's parallel to the ground. So here's your 90-degree angle, and you're 28 feet from the base of the flagpole. The angle of elevation to the top of the flagpole is 63 degrees. So this is 63 degrees, and it is your theta. That is your theta. And therefore, let's see what they're asking us to do. Estimate the height of the flagpole. So we want to know what this height is, and let's call it x. So we don't know from theta, we don't know the opposite side, but we do know, we have to know one of the values. We do know the adjacent. Notice this has nothing to do with the hypotenuse, so that rules out sine and cosine. So to do this problem, so Sohcahtoa, and we are interested in this one right here. Okay, so we want the tangent of 63 degrees is equal to the opposite leg, which is x, over the adjacent, which is 28. Multiply both sides by 28. 28's cancel, and you're left with 28 tan 63 degrees. So do the 63 degrees, or 63 in your calculator, hit tangent, then times 28, and you're going to get x to be about, it's like 54.8 something, and I just rounded it to 55. So the flagpole is approximately 55 feet. And those are your notes for today. Have a great day, Algebra 2 students.